Hello, I'm Dr. Andy Hales at the University of Mississippi, and in this video we're going to look at how to filter cases in R. So, sometimes when we are working in R, we want to look at analyses or results with some of our observations, but not all of them. The way we can easily accomplish this is by using the filter function from the dplyr package, which is part of the tidyverse. So as always, we're going to load up the tidyverse package, read in the data, and a few of the variables that we're going to be working with today, gender and the estimates of Skittles. People were asked to estimate how many Skittles are in a bag, and that's what we're looking at. So for starters, let's just give ourselves a histogram of the distribution, including everybody. This is with all complete cases in our data set. Cool, but suppose we want to know what the results look like just for men. Well, we can do that by using filter. So we can ask R to filter the data and only include cases where gender is equal to man. And so if we look at our data itself, we have the gender column, we have a missing value, we have most cases here are man or woman. When we run this, we get a new data set that has only the 8 observations where gender is equal to man. And now that we have this, we can perform the same histogram as earlier and see what the results look like with just men. Of course, we could do the same operation for women, and we get a different looking histogram. Cool. And now we have 3 different data sets up here, one with everyone, one just men, one for women. That works. Now we could also, if we wanted to, this is icing on the cake here. If you get it, you get it. It's fine. But sometimes it's convenient, if we're working with the pipe and the tidyverse here, to perform filtering on the fly so that we don't end up with a million extra data sets in our environment. They're not hurting anyone, it doesn't matter, but it's another way to go about things. So we can take our data and we can perform whatever filtering we want to perform before feeding it along to the histogram here. So what does that mean? Well, let's go back and create our original histogram, including everybody. Suppose hypothetically, in real life, this would be super questionable. I'm illustrating how to perform data management here. This is not something you would seriously actually do. But suppose we wanted to see what this histogram looked like with the cases removed where the score is greater than 75. So we want to trim those away. Maybe we decide those are outliers and we want to look at the results without them. If we were performing any hypothesis tests with p-values, this is exactly the sort of decision we'd want to pre-register ahead of time so that we aren't biased to report the more favorable results. You know all this. But to see the filter function in action here, we can take our data, we can filter it to only include cases where the estimate is less than 75, and then pass the data along to the rest of the ggplot, and we get the histogram that you'd expect. Here, let me get out of the way so that you can behold the magnificent histogram here. That's how it's done. So as always, what happens in R stays in R. The reason this is so convenient is you can filter out cases to perform your analysis, and your original data file, wherever it's living, is untouched. And because you're saving your code, you have a record of what you've run. So it's easy to go back and see what's there. So there you have it. That is how you filter cases in R.